Morning everyone, welcome to this webinar on a very special day for Rockflow Dynamics as we celebrate our 20th anniversary. We've got lots of exciting celebrations planned to celebrate this milestone, so hopefully some of you can join us for our Global Technology Summit Roadshow. I think, Alexi, if you just pop to the next slide, you can see that we've got 9 events planned in May, so hopefully you can join us at some of them to celebrate. So in today's presentation, back to the webinar, my colleague Alexi will demonstrate how the use of integrated production modelling workflows in tNavigator can allow you to optimise your well production and carry out more efficient geothermal energy extraction. Alexi, can you go to the next slide, please? Thank you. So just to let you know that everyone who's joined the webinar today has been automatically muted. So if you'd like to ask a question, which we encourage you to do, please pop that into the chat function and we have some time to answer those at the end. And we are recording the webinar, so we'll upload that to our YouTube channel later on today. And of course, if you have any other questions or any follow-up, you can drop us an email on asktnav@rfdyn.com and we'll get back to you. Cool, so I will hand over to Alexi and hope you enjoy this presentation. Thanks, Alexi.
Thanks, Joanne. Yeah, can you see my screen now? So nice to see everyone and thanks for joining. So my name is Alexi. I'm a petroleum engineer by background, so I'm based in Aberdeen doing support for RFD team. So today we're going to talk briefly about integrated asset modeling, how we can use this approach for geothermal projects. So we developed it in the TNAV in the last 2 years quite heavily. So it's good, and we have a lot of requests from the clients how we can apply this approach not only for geothermal but also for the CCS. But today we're going to be focused on the CCS functionality, so for geothermal functionality, and how we can use integrated asset modeling approach to optimize the geothermal projects and enhance heat recovery and optimize the project potential in general. So talking about about the geothermal and talk about IPM. So the idea is to connect all elements of the system into one model. So we have our surface model, so we can also do the well modeling in quite details. And today we'll try to be focused on how we can use these well models for optimizing the completion, calculating the temperature, and analyzing the well performance in general for the long-term forecast and for the short-term optimization. Going to the next slide, so we have a look on the well projects. So regarding to the geothermal, so we can do the completion modeling, and afterwards we can start to investigate how the temperature distributes along the wellbore and what kind of temperature losses takes into account for that particular producer or injector. So and afterwards we can do some kind of optimization on completion side. So we can also optimize the temperature, we can try to optimize the well design and minimize the temperature losses, or trying to find the optimal production rates of the brine, or the optimal injection rates for injectors, and see how the temperature is distributed along the completion. So and also it's all coupled with the reservoir model. So we have the well process connected to the subsurface, so we know that how the temperature in the reservoir changes on every calculation time step. So and afterwards we can connect it with the surface models, and because for the geothermal project, so surface production and production facilities, they also play quite crucial part, I think. So and we need to capture how the temperature changes of produced brine from injectors, from producers to the production facility. So how much heat we can extract, and also how we can optimize the pipelines, and how we can implement the best strategy to produce the brine. And the same for the reinjection system, how much we can reinject back to the reservoir, what is the temperature, and how much temperature losses we have. And we also can enhance it with some customized functionality in tNav, and we can add more flexibility to the project. But the main idea, not to explicitly specify the injector temperature of the fluid, but make it more realistic and capture all the temperature losses from producers and up to reinjecting back to the reservoir. So let me just go back to the model itself. Let me just share the model that we have. So so we started to have a look on our subsurface side and antenna, so we can couple our reservoir model with the wells and the surface facilities as well for the geothermal projects. So we have a Blackwell model with a temperature option, so which captures all the, like a temperature loss, temperature calculations within the reservoir. So, and on top of the reservoir, if you have a look here, so we have more elements implemented. So we have our 4 producers and we have 1 injector. So the idea is so to see how much brine we're producing and how much brine we can reinject back to the reservoir, and run it as a coupled model and capture all parameters on every calculation time step instead of specified explicitly. So we have a look on the project structure. So we also have more elements on top of our reservoir. So this is the advantage of IPM. So because you have more, you can create like more realistic project, and you can capture like additional elements that you can't really capture with the standalone reservoir model. So we can start with our producers. So, and we can have a look on what we have in here. So we have a completion scheme, so which is pretty straightforward. So we have a calculated VFP curve, and we have an access to our PVT model on top of that. So in case of geothermal, it's a bit more simplified because we have like a single phase flow. But we can, the key thing and the key idea is to see how much temperature losses we have along the completion. So if we have a look on the well construction, so we have our tubing and we know where the perforations is located. So afterwards we can have a look on the heat transfer tab, and this is the place where we are specifying the parameters here. So we know our temperature, our reservoir temperature, so which stays as a bottom hole temperature. So we can also specify the heat transfer coefficient as a constant value, but we also can assign the heat transfer coefficient versus the depth, so it provides for you more flexibility. And also we have an options if we go to the segmented well model, so we can capture, instead of specifying like a heat transfer coefficient explicitly, so we can add the tubing, we can add the thermal conductivity of the casing, thermal conductivity of the tubing, and we can calculate it more in more details. So, but today in this particular model we have a constant heat transfer coefficient, and we can have a look on the well profile, so which helps you to understand. Okay, so we know how much brine we can produce. So, but we also want to see how much the temperature losses we have on in our model. So, and we can visualize our parameters here. So we have a more flexibility. So we can visualize the pressure, how the pressure distributes from the bottom hole up to the wellhead. So, and also we can visualize the temperature parameters here as well. So let me just switch to injectors. So the same idea for injectors. So we know we can optimize the completion scheme of injector, and afterwards we can see how much how much capacity we have for that, how much we can inject back to the reservoir. So, and we can have a look on the well profile. Sorry, just let me go. There's maybe visualize it better here. So again, we can visualize how much how the temperature changes, and what is the heat losses from the bottom hole and up to the wellhead, and the same for the injectors. So this is the way how we calculate the temperature losses on our well level. So, and afterwards, if we have a look on our network model, So we have more elements here. So we have our flow producers here connected to the manifold, and we have our production system, which basically transfers the fluid from the manifold up to the production facility. And on top of that, so we have our injection system. So we know how much we're producing and how much we can reinject back to the reservoir. Sorry, let me just switch to the screen. Yeah, so we can scroll the slider, so we can basically, sorry, just yeah. So we can visualize the results on every calculation time steps, and we can see how much actually we how much we produce on every calculation steps, and how much temperature losses we have. So also, instead of specifying in this case, so we don't really need to specify the temperature of the injected fluid explicitly on every calculation time step. So it's going to be calculated based on how much fluid we produced and how much temperature losses we have along the pipelines. So we can have a look on very details, in very details on how much, what was the description of the pipeline, and we can select the heat transfer coefficient, and we can play with it and see what is the optimal heat transfer coefficient to deliver much of the heat to the production facility. And also, we can, instead of specifying like a heat transfer coefficient, we can play with we have much more advanced options for the description of the pipelines. So you can select the thermal conductivity of the layers, and you can assign like the thickness of the layer, and you can select the number of the layers. And in that case, so the heat transfer coefficient is not taken into account. So we calculate the temperature losses based on the pipeline description and based on the thermal conductivity of the layers. So we also have more functionality with the Python. So if you need to specify something more customized, so you can select, you can add the Python logic, and you can control the temperature of injected fluid back to the reservoir. So, and you can add more customized logic if you have in mind how the treatment facility works. Okay, so I have some minor issues with my laptop. And afterwards, we can go back to the grid, and we can visualize the results in the grid. So we also have like a nice visualization results on the 3D view. So basically, we can see how the temperature here changes versus the time. So basically, the temperature of injected fluid here comes from our injector. So, and we know, depending on how much we're producing and how much heat we're extracting on the surface side, we know how the temperature in the reservoir is going to be declined. So it helps you to understand in more details what is like the best way to produce, how much brine you can produce, and what is the parameters of and basically how the reservoir performs. So because depending on how much heat losses you have in your production facilities, wells, and the surface facilities, so it will affect the temperature profile in the reservoir model for sure. So in that case, so we know the temperature of injected fluid on every calculation time step, and we can visualize results on the grid. So we can also visualize results on the pipelines and see how the pressure or temperature in the pipelines change from the source of the fluid for injectors and up to the wellhead of injector. Yeah, I think that's all from my side. I think it was like a brief description of the project of the model we have. So if you have any questions, so you're very welcome to ask.
Thanks, Alexi. I'll have a look and see if we got any questions coming through. Cool, yeah, we got one here asking, Alex, you can just keep the screen on, I think.
Yeah, just give me a second, please. I think my screen was frozen for a second, sorry.
Cool, thank you. Okay, are you ready for a question? Okay, what's the type of model that you've used here?
Yeah, so in that case, we've so we have different types of the model we can use in tNav. So we also support geothermal model, thermal models. But in that particular case, so we used the Blackwell model plus temperature option, which is should be quite enough for the geothermal project, because like the fluid model is more or less simplistic. So we have just almost like a one phase. So in that case, the Blackwell approach with the temperature option is quite good. So we don't really need to overcomplicate the model with going to the thermal models.
Cool. And another question here, how can IPM enhance management and optimization of the geothermal project?
Yeah, so this is the main idea of the IPM approach. So you have an access, you can make like, first of all, you can make like a more realistic model of the project. So you have an access not only for the subsurface model, but also for the wells surface facility and the like the surface facilities. So you can do much more optimization. So because you have a more realistic model and you can optimize the operating and capital expenditure of on the project by understanding how much you can produce and how much you can reinject.
Cool. Okay, we've got a lot of questions coming in. Hang on, just let me check. Okay, have you benchmarked the elements, as in reservoir, well, etc., of the coupled system separately or all together? And then there's a little follow-up on that one too that says, and also to make sure that the well lateral heat exchange is working accurately.
Yeah, so you can start like the usual practice is to start the model elements separately. So you can start with the subsurface model first and calculate the subsurface, run the subsurface model and see how the reservoir performs. Afterwards, you can add the wells and you can match the well models on the real data. So we can support this functionality in Well Designer. So you can calculate like a temperature profile along the wellbore versus the real measurement, really measured temperature for producers or injectors. So afterwards, you can move to the coupling. So you can couple your subsurface models with the wells and see basically how this coupling works and how, talking about like geothermal, how pressure and temperature distributes and how basically the well performs, etc. So, and afterwards you can add more complexity. You can add a network model on top of that with the surface facilities and the QC it as well. So basically we suggest to make like a QC on every step of integration because every new element of the model can differentiate the results or like alter the production profile because it's more elements involved in it and you have more controls.
Great, thank you. One more question here, maybe we'll just do two more, I think. Are you running a finite difference calculation in the reservoir grid and nodal analysis for the wells and pipelines?
Sorry, John, can you repeat it again, please? Sorry.
Yeah, sure. You can actually see it if you want to pop out the little box, you'll be able to read it as well. But it says, are you running a finite difference calculation in the reservoir grid and nodal analysis for the wells and pipelines?
Yeah, so so this is like a fully coupled project. So so in this case, we don't really transfer like the results as an IPR, like a nodal analysis for the pipeline. So it's a absolutely so in this case, like a network model or pipelines, as you mentioned, they are fully involved into calculation. So we have the same calculation time steps for subsurface and for the pipelines and for the wells. So we don't really need to make like an additional like nodal analysis on the pipeline. So basically we know how much fluid we're producing. So basically we know what kind of correlation we have for the pipeline. So we know the performance of the pipe, or like the VFP performance for the pipeline or the well. So, and based on that, we calculate the pressure losses along the pipeline. So we don't really do like we don't do it like separately. So this is like a one system of equations which solves on every calculation time step. So, but if we do support this functionality if you want to make additional like a one-time step nodal analysis or for the pipelines or for the wells. So it's also supported.
Great. Okay, cool. Thank you. We've also got a question that says, can I have this model as an example? I'm sure that you can share some more details. Would that be right, Alexei?
Yeah, absolutely. So we can if you're interested to have a look on that model. So this model, like this is the demo project, and I can share it, and you can have a look on it in more details. So basically, you will be able to see like all the elements involved in it and how they works together. So you can also have a flexibility. You can analyze like a well performance separately, pipeline performance, and reservoir performance separately before coupling can go into the IPM project. Sure.
Thanks. Cool. I think there's a couple more questions, but we can probably just leave it there for today. And if your question wasn't answered, Alexei will drop you an email with some more information. Alexei, can you go back to the slides, please, if you still have it there?
Yeah.
Thanks. Cool. Yeah, so just to let everyone know, our last webinar in this little mini series is next Tuesday, and we're back to geology topic. So it's going to be focusing on geological uncertainty. So hope you can join us, or feel free to share with your geoscience colleagues as well. And there's Alexei's email address there if you need any more questions. But yeah, hope you enjoyed the webinar today. Thanks, Alexei, and thank you everyone who joined. See you next time.
Thank you.